Welcome to today's lesson. Today we shall be looking at what? Sound. Say sound. Sound.
Sound is a form of energy that vibrates, okay? Sound is produced when there is what? Vibration. Can you see the guy clapping his hand? Yes. When he claps his hand, sound will travel through a material medium such as air. When sound travels through such a material, we say it is what? Sound wave. So sound wave enters our what? Ear. Where do we get sound from? We get sound from one of the oldest form, which is called the human voice, okay? Our voice is the oldest form of sound. Also, insect also what? Make sound. Some insect make sound, yes. Then the other forms of sound that we get are from where? Musical instrument, okay? Robert Boyle was the person that discovered how we hear sound. Robert Boyle said that we hear sound because sound is carried from the source, which is a vibration, through particles such as air to our what? Ear. How did he know? He took a ticking clock and put inside a glass jar, and then he was able to hear the ticking of the clock. But he later pumped out all the air or sucked out all the air from the ticking clock, and he discovered that he could not hear the sound again. That made him to conclude that sound actually travel through materials such as what? Air to what? Our ear, and it is vibrated by our eardrum down to our what? Ear. So sound travel through solid, liquid, and what? Gas. It will interest you to know that sound can travel through solid, liquid, and gas. Sound travel fastest in solid and slowest in what? Air. Okay. Fastest in what? Solid, followed by what? Liquid, and lastly what? Air. Just like the way we measure temperature, we also measure sound. Okay. The way we measure temperature, we can measure sound. What do we use to measure sound? We use a sound level meter to measure what? Sound. The unit of temperature is what? Degrees Celsius. What about the unit of sound? Sound is measured in what? Decibel. Say decibel. Decibel. Write this as a dB. Okay. So high sound, when it's too loud, we call it what? Noise. All right. Let's look at some properties that we use to describe sound. This diagram shows a sine wave. Say sine wave. These are sine wave is or sound wave is. Okay. Sound wave is a sine representation. The frequency is the number of circles that is covered in 1 second. So let's say this 6 circles we see here is covered in 1 second. That means the frequency is what? 6. Frequency is the number of circles covered in 1 second. While the wavelength is the distance from the top of 2 circles. Okay, we can say the peak of 2 circles that follows each other is called the what? Wavelength. Wavelength is the distance of 2 circles that follow each other. All right. While we say the amplitude is the loudness or the highest volume of the what? Sound. Another property we call echo is when sound hits a plane surface and then bounces back to you, or we call it reflection of what? Sound. There's another property of sound we call what? The pitch. The pitch of a sound is how high or low the sound can be. Look at this keyboard. This keyboard has in the octave different keys of C, is it not? From high pitch to medium pitch to what? From low pitch to medium pitch to what? To high pitch, okay? So the faster the vibration, the higher the pitch. I take it again. The faster the vibration, the higher the pitch. So the vibration in the first C key there is slower than the one in the middle, and then the one at the end is actually what? Faster. That's why it gives a what? A high pitch. All right. The pitch also affects the wavelength. Because of the speed of the pitch, we say that shorter wavelengths have higher pitch. I take it again. Shorter wavelengths have higher pitch, okay, and vice versa. Sound cannot be heard there. So an astronaut in space will not hear sound when we travel to what? Space. Why? Because there is no air in space, okay? Unlike planet Earth here, there is air. That's why I told you just now that sound is carried through what? Vibration, and it follows a material medium such as what? Air, which is vibrated to our what? Eardrum. Okay. The wind can also affect our sound. If you are talking against the wind, you will not be heard. But if you are talking to the direction where the wind is going, the wind will easily carry your sound to the other person's what? Ear. There are some materials that do not allow sound to pass through them easily. I will call them what? Soundproof. Okay. Say soundproof. Soundproof. A very good example is this device you are seeing here. Okay. This device I see is called an earphone. Is it not? It blocks your ear from hearing anything in the environment. Sound also have positive and negative effect in our environment. Imagine that we are living in a world where sound does not exist. How are we going to communicate? How are we going to understand each other to be very bad? Is it not? Yes. So sound has helped communication to be much more better. Even our movie watch at home, but sound is also not good because sometimes it destroys our eardrum when it's too high. And again, someone can decide to be playing earpiece music and walking on the road, whereby it can get accident. Is it not? I want you to watch this video. Pay attention to the two types of sound wave.
Vibration is the back and forth movement of an object. As you speak, vibrations are produced by the vocal cords in the throat. You can hear only when the sound energy reaches your ears. But how does sound energy travel? Wonder how that works? Come, let's go across to Dr. Zook. Sound energy travels in the form of sound waves. There are mainly two types of waves, transverse wave and longitudinal wave. Let us see how waves travel. We can use a slinky spring to observe both types of waves. Emily is holding one side of the slinky, while Dr. Zook is holding the other end. With a quick upward flick of the wrist, Dr. Zook has sent energy traveling through the slinky. Notice how the slinky moves? This is a transverse wave. In a transverse wave, the particles vibrate at a right angle to the direction of the wave. The wave traveled from Dr. Zook to Emily and back. Now let's see what a longitudinal wave looks like. Emily is holding one end of the slinky, while Dr. Zook is pulling its other end towards himself and then pushing it towards Emily. Watch closely and you will notice that some of the coils crowd close together and then slowly move farther apart. This is because the vibrations are parallel to the direction of the wave. If the wave moves from right to left, then the particles also vibrate from right to left. This is a longitudinal wave. Sound waves are longitudinal waves. These waves travel at different speeds in different mediums. The medium could be a solid, liquid, or gas. Sound waves travel in all directions.
Emily?
Sound gets reflected. That is, it bounces back on hitting a solid surface. Bouncing back of sound is called echo. Bouncing back of sound is purposefully used in detecting depth of seabeds. That's amazing, isn't it?
Come back from that interesting video. I believe with this lesson you now know sound is a form of energy. You now know that sound travel in waves. You now know the sources of different sound. You know the properties of sound, and you know that sound is a longitudinal wave and a transverse wave. We also hear sound as a result of vibration of sound, through sound materials. Is it not? Yes. And finally, you also know that there are some materials that do not allow sound to pass through them, and they are called soundproof. That now brings us to the end of today's lesson. I want you to do all the other activities in this class and stay safe. I'll see you soon.